Hey folks, happy Tuesday. We're moving on to some new stuff here. We're going to talk a little bit about sorting and selection. So we did cover the basic sorts, like a selection sort and an insertion sort last semester. So we're going to skip over those, and we're mostly going to jump into the merge sort. So there's a couple sorts that it looks at here in the sorting selection chapter. We're just going to talk about merge sort. You'll get into some of the interesting ones later when you continue on in 350. So we're just going to look at merge sort. And the deal with the merge sort, this is a recursive divide and conquer. So the book has a nice illustration of it here. So if you give it a list of values here, what we want to do is break it into smaller pieces and smaller pieces and smaller pieces and smaller pieces. Eventually, the smallest piece, a size 1, is sorted. So that's the divide piece. And then as we start putting them back together, we start merging them back in, it's really easy to take two lists and say, okay, let's put the two lists in order. So what you do is you start at the beginning of each list, and you're going to see, okay, which one is smaller? That one goes first. And then that list 1 or list 2 moves, you increment. And then which one is smaller? And then increment. And then which one is smaller? And increment and increment. And you just keep on going. So that goes really quick for merging two sorted lists. So we just keep on going down and down and down until we have small lists. So you put them back together in a bigger list, put them back together in a bigger list, put them back together in bigger lists. So we'll be able to do this in logarithmic time. So the end of this merge sort is really an n log n operation, which is really fun. So I start up a new project here for merge sort. So we're going to have a merge sort function here. Define merge sort. This needs some list. Right? We're going to sort this list. Now, what we want to do is we're going to have a recursive bit here where we start dividing this list in half. So our base case here, we can say, hey, if the length of some list is less than 2, we're done. There's no more work that needs to be done here. If it's more than 2, we have to find the midpoint. So middle index is going to be the length of some list divided by 2. Right? And we want to do the floor division here. So then we'll have the first half is going to be a slice. We'll take our sum list and we want to slice it from the beginning to the middle. Right? And then we'll have the second half is going to be sum list, and we want to slice from the middle index, that one here, from the middle index to the end. Right, so now I have the two halves, so we split it in the middle. Then I want to recurse. I want to merge sort those. So I'm going to call merge sort on the first half. I'm going to call merge sort on the second half. When that's done, then I'm going to merge the first half, the second half into some list. Right, we don't have merge yet, so we'll get to merge in a minute. Right? So then we'll write our merge function here. So merge takes a couple things. It takes the first half, it takes the second half, and it takes the sum list. Right? So we're going to take from the first half and the second half, put them back into some list here. So we need to see which one is smaller, and all of this is going to go until we reach the end here. So a couple ways of going about it here. We can say our first half index starts at 0. We can say our second half index starts at 0. And then we're going to keep on going until we reach the end here. So we can say while the first half index plus the second half index is less than the length of some list. Right? So one quick way for us to do this here, right? So we need to see which one is smaller. So if the first half index is, if the first half at the first half index is less than the second half at the second half index, then we know the first half is smaller, right? So we're going to take our sum list at the first half index plus the second half index, and we're going to assign it the first half index from the first half, right? So this is, okay, if this one is smaller, put it in this location. If it's not, then once we've done that, now our first half index goes up by 1, right? Move this one here, right? As we take those two lists, we see which one is smaller here, right? So if we were to draw a little picture of our two lists, we do a merge here. Sometimes that's helpful to draw that out. So we might have like 3, 7, and 9, and then maybe we'll have 4, 6, and 8 in here. So those are our two lists, and we're going to put them together in a bigger list, right? So our bigger list here, we've got 1, 2, 3, 4, 5, 6 spots. So we look at the first one of each. We say, okay, which one's smaller? So the 3 goes in, and then the next one of the first half becomes 7. Then we say, which one is smaller? Okay, the 4 is smaller, and that moves on. And then which one is smaller? 6 or 7? We put the 6 in, this one moves. Which one is smaller? 7 or 8? We put the 7 in, that one moves. Which one is smaller, 8 or 9? 8 and then 9. Right, so we just keep on going with those. So if our first half index is smaller than the second half, we put the first one in, and then if it's not smaller, then we'll just take the other one. We'll take the second half index. Again, the same location here, but now we're going to take our second half at the second half index and drop that one in. Now, this works well, but if we get to the end of the first half, we're going to have trouble comparing indexes, right? Got to be a little bit careful with that. So once we're done, right, if we reach the end of either one of those, then we just take the rest. So if, like, say when we split those up here, let me just scroll down here to like a new list here. If we had, 1, 2, 3, and then 4, 5, and 6, right? We'd say which one is smaller, 1 or 4? Okay, which one is smaller, 2 or 4? Which one is smaller, 3 or 4? Once this one moves, there's nothing left here to compare, right? So we also then want to make sure that we're only doing this. Well, this one is true. And then our first half index is less than the length of the first half, and the second half index is less than the length of the second half. There's our backslash, right? Okay, we got a backslash in here. So once that's done, one of them might still have a value there. So then we can check real quick to see, hey, if there's any left here. So if first half index is less than the length, or I guess we'll just do a quick loop. We can just say while the first half index is less than the length of the first half, we can just drop them right in, right? So we don't need this first if check. We can just start dropping values in here because we know we couldn't have got here if it wasn't less than, right? And then we'll repeat this for the second half as well. So while our second half index is less than the length of the second half, then we'll take the second half at the second half index and increment that one. So eventually then we'll get to the point where this one is filled up, right? So we'll do while the first one is less than the next, and we still have some values, right? So when one of these becomes false, the whole thing stops. We don't need to keep checking anymore here. So really, I think we can actually just do the first bit here. I don't think we need to check both, right? I think we can just say, hey, as long as this one and this one is less, right? I think that ought to work for us. So that should merge those together then, right? And then merge sort just keeps on recursing here with this one. So let's see if it works. So we'll give it some values is, what do we have here? 7, 3, 5, 8, 12, 15, 21, 9, 2, right? We should be able to call a merge sort on my sum values. And then we'll print some values. See what we get here. If it works, it'll be amazing the first time. 2, 3, 5, 7, 8, 9, 12, 15, 21. Look at that, it worked for us. Didn't even crash. Pretty cool. So that's all it is. So it's this recursive bit here of dividing and conquering, right? Just keep on going, breaking into smaller pieces and then merging them together, merging them together, merging them together. Now, this is not super memory efficient, right? Because we're going to be passing lots of copies of lists around. We're not super concerned about that at this point, but just know this is not efficient to pass copies around memory-wise, but that's all. All right, so that was the merge sort. Again, there's not too much more we're going to tackle in searching and sorting. We're going to save most of that for later here. So we've got lab later today. On 4-4, unfortunately I won't be able to make it, so take that time to work on your group project. My son's robotics team made it to the state finals, so we're going to be up at Saginaw Valley State University all the Thursday and Friday, and then hopefully Saturday if they do well enough to make it to the playoffs there. So I won't be around on Thursday. I'll have my phone with me. If you want to call me, send me messages, text me, whatever. I'm happy to hop on and help you work through any of that if you want. I just won't be here in person for it. So we'll take all of 4-4 for group project work time, and then we'll come back on 4-9. We'll talk about ethics, do our lab on ethics, and then we'll start wrapping it up. So we're looking forward to it. If you got questions or concerns, let me know. If that's it, I will talk to you folks later. Take care.